All right, so you're joining us back on lesson 19, and we're here where we need to find the coordinates of the fourth vertex or corner of that rectangle. And so I did that, and I plotted a point right here. And next we need to explain how we did that. So I just did it by counting because I know that this is a rectangle. So, however long this line segment is, this one needs to be also. So since this was 9 units across, because it told us to make it 9 units, then that means that from here to here need to be 9 units. And I actually did that with no math at all. You don't really need math for that. So I'm going to write my explanation. Okay, so here is my explanation. Because the opposite sides of a rectangle are the same length, I counted 9 spaces to the left from 4, 5, the ordered pair 4, 5. You could also use absolute value, and here's how. So I just counted 9 spaces to the left from here, but I could use absolute value because I know that this from 0 to here is 4 units. So this is the absolute value of 4. And I need to go a distance of 9. So going back down here, here's how you would use absolute value. I know that the absolute value of 4 is part of what we need. Sorry, let me scooch that. So the whole distance needs to be 9. So I'm going to subtract from that the absolute distance, the absolute value of 4. That means that, whoa, where did we go here? Have work on this thing. So to find the other point, we're going to need to go from 0, and we're going to need to go this many spaces. Oops, 4. We're going to need to go 9 minus 4 spaces from 0 to the left, which would be 5 spaces to the left. That is a little more confusing. In this case, it was a little bit easier just to count. Next, we need to explain how does that fourth vertex, that fourth corner, relate to each of the other vertices or corners in either direction. So really what we're explaining is that when you add in the ordered pair or the location of this coordinate, once we have it labeled, we can see that it has a 5 in the y as the y coordinate because it's on the same axis as this one. So it's just asking how do they relate? Well, this one and this one have a 5 as the x-axis because they're on the same line. And this point and this point have a 5 in the as the x coordinate because they are on the same place on this line. So because it's the same distance up as this one and the same distance across as this one, then it's going to have some of the same coordinates as some of the other corners. That's really all it's asking. So we're going to go down and write our explanation. Okay, I've got my explanation. It's what I just said. Has the same x coordinate as this one. The x is in the same place, -5, because they're at the same point on the x-axis. They're the same distance across going left to right because they're part of a rectangle. It has the same y coordinate, the second number, 5, as this ordered pair or as this location for 5 because both of them are at the same point on the y-axis, the up and down part. They're in the same line. So then it says to draw the remaining sides of the triangle. Let's make sure we still got blue. Blue. There we go. So we're just going to complete, did I say triangle? I meant rectangle. We're going to complete our rectangle. Bam, there you go. We made a rectangle and a graph. Using that same rectangle, we're going to find, let's see, using the vertices that you have found in the lengths of the line segments between them, find the perimeter of the rectangle. Oh, that's easy. Okay, so perimeter means the length or distance around. So we're looking at our rectangle here, and we remember we were told to do 9 units for our horizontal line segment. So that means that Let's make you really big. And maybe not red. Let's do orange. No. So that means that this here is going to be 9 units. So let's go ahead and label that if the bottom side or line segment of a rectangle is 9 units, then that means that the top is also going to be 9. No, you come back. But it's a rectangle, and I want to make sure that I know how many units this is. So for this one, I could use absolute value, but I'm just going to go ahead and count. So it's a little easier to do without all those little boxes. I'm going to use my finger. 1, 2, 3, 4, 5, 6, 7, 8. So the left side has a length of 8 units, and that means that the right side would also have a length of 8 units. To find the perimeter, we add all those numbers together. So let's go back down. And here we go. Our perimeter is going to be the two sides that have a length of 8 units plus the 2 sides that have a length of 9 units. So 9 and 9 is 18, 8 and 8 is 16, 16 and 18 is 6 and 8 is 14. So it's going to be 34 units. Double check my math. That was pretty easy to do. So then it says to find the area of the rectangle. Let's take it back to, goodness, I think this was 3rd grade, 4th grade. Finding the area of a rectangle. For the area, I don't need you anymore. We're going back to our same rectangle we drew. Area is going to be length times width. So this is 9 units long and 8 units wide. So we would do 9 times 8. Okay, so 9 times 8 would be units. That's the area. And I'm going to let you solve that and fill it in yourself. Oh, you know what? I can't. I don't know how to do the squared on here, but it's actually square units. So we need to put our little upside down caret and say that it's square units. Okay, there we go. Because area is square units. That should really be a tiny 2 up here, but I didn't put it. Okay, moving along. We're still working with that same rectangle. Okay, number 6 says to draw a diagonal line segment, so it's going to be going at an angle, through the rectangle with opposite vertices for endpoints. What geometric figures are formed by this line segment, and what are the areas of each of these figures? Don't freak out. It's actually very simple. So we're going back to our rectangle, and it says to draw a diagonal line. You could have yours go this way or this way. I had mine go that way. And then it says, what is the area? Well, okay, what geometric figures did we form? We made 2 triangles. And then what is the area of each? So rather than go through and try to count each of the squares and figure out how many half squares there are and put them all together, and also rather than try to figure out, okay, the area of a triangle is 1/2 base time height, you don't need any of that. We basically cut our rectangle. I'm just going back to my rectangle. We cut it in half, right? So let's take the area that we originally found, which was 72, and we're going to cut that in half. So half of 72 would be our area for each of those triangles. All right, we're going to wrap it up here. So here's my explanation. They each have an area. It's going to be the rectangle's area, which is 72, divided in half, or 36 each. I'm going to follow up with number 7 in the next video.